So today we're going to talk about anomaly detection, specifically using it on Oracle performance data, and show a few experiments we did. I'll be presenting with Alex Morris. Just a few introduction in the beginning. So my name is Alex Gorbachev, work at Python, I'm a CTO, blogger, been around for a while, engaged in the community in various ways, and Alex is also working with me as chief data scientist at Python, and I'll let him introduce himself better.
It's a pleasure to be here. Thank you for sitting inside on such a beautiful day. So I spent several years in academia. I was a string theorist and theoretical physicist working on beautiful mathematics, and left academia and started doing data science. And it's really beautiful because data science in this era is based on much of the same math that physicists know and love. So it was a fun transition to make. I've been now almost 5 years in doing commercial data science and machine learning, and it's really wonderful to be working with Alex at Python, and apparently I'm also a cool guy.
I wrote his slides, so anyway, so I'll just introduce anomaly detection and how it's different from a variety of other machine learning sort of algorithms or methods. I also show you how you can sort of implement reasonably easy sort of black box sort of anomaly detection solution based on open source components available. And then I'll show how to use Oracle data mining anomaly detection algorithms in there. And then Alex will introduce some of the Python tools and what you can do there as well. So traditionally, when people think about machine learning, we think more about supervised algorithms like classification is a typical one. When we have a data which is labeled, so in this case, label of a Y column, so it's a class, let's say A, B, C, or whatever, how many classes we have. So what we could do with this data, we can then look at take this data as a training set and train a model so that based on this input features, it can predict the class, right? It can predict the class, predict this labeled data. And we can then apply it to the data which is unlabeled, right? So the future data generated, right? And then we can classify in one of those classes. So it's easy to evaluate performance of this algorithm, of this model, because we can simply split our labeled data in, let's say, 2 equal parts, and then train on one part, and then see how it performs on another part, right? And see whether it's actually classified or labeled the data as it's already labeled, right? Now, with anomaly detection algorithms, it's not as easy because the data comes as unlabeled. So, and what we're trying to find is trying to find those data points in a data set which looks very much unlike the rest of the data set, right? It looks anomalous, right? Depending what type of data we take as an input, we, obviously take different anomalies. Like a common industry example would be like a fraud detection, right? When transaction looks unlike most other transactions than typical users do, right? So why is it useful in Oracle sort of performance world? Well, we traditionally monitor server performance, database performance by certain metrics and setting certain thresholds. But if we're working with a large amount of metrics, a large amount of servers or databases, it's very difficult to set those thresholds properly, and they're also dynamic and change in time as well. So as a result, sometimes it's just a loss and loss of effort. So it'd be nice if we can detect. So that's an example of let's say just a single metric that we collect, and it's somewhere here, and then this spike would be looking like an anomaly. But if you look at the metric which has sort of multiple features, so that's example of the 2 variables, right? So you can see that this is basically how the data typically look like, right? And these points are anomalous. So it's not only a single metric that has like a spike, but it's a combination which I rarely seem to get in this example, right? And when we look at sort of multi-dimensional space, they don't visualize as well. But the idea is that there are data points which somehow unlike the rest. So applying anomaly detection algorithms to performance data and Oracle performance data will basically let us try to identify the point in time, for example, or for example maybe SQL statements which look unlike others. And that means they may consume too much resources, they may run inefficient. It may be that this period of time that is anomalous, something happens that we need to pay attention to. And if we build a model, we can apply that in real time as a new metrics gets collected, so it can actually be embedded into like a paging algorithm. So this is what we've done about a year ago when we took over large, it wasn't Oracle, but we took over large Hadoop cluster deployment a few days before it went into production, before the launch of the product, which collided with Super Bowl, because that's how they advertised that. And it was interesting because we basically had no time at all to look at like 100 servers and figure out, which out of tens of thousands metrics we'll need, because we didn't have the baseline for the workload, and we didn't even have like any workload because it's literally just about to be started. So what we've done in that case, we've basically deployed the open source solution Kale Stack by otw14, which is totally open source and it's being developed. So the way that it works is that you have sources of operational metrics, let's say our databases, or in our case it was servers and some Hadoop components, daemons and so on. And then there's a package, also open source package called Graphite, which has Carbon component inside it. And this is basically a package which lets you collect and manage a lot of time series data. So it's totally open source, so you can set it up easily. And what's possible with Kale Stack is that it's possible to set up this Graphite Carbon as a relay meaning basically replicating data. So as data coming in from a variety of sources, we can replicate it to another, as if it's to another Graphite instance. But instead of replicating to a Graphite, it's actually replicated through to this Kale Stack and written into Redis database. So there's a link down there. I assume we post slide somewhere. There's a link down there which actually has presentation how this whole component works. And the Kale Stack includes Skyline, which is basically anomaly detection package on their time series data. And what they do is they come up with a few algorithms, and then they, when those algorithms sort of detect an anomaly, they sort of combine the results together and try to come up with a sort of anomalous metrics. And the Oculus component is then, when you detect an anomaly, when an anomaly is signaled, the Oculus component will try to correlate those detected anomalies with other metrics, and will try to find similar anomalies. Those metrics that correlate together, they look similar, and they behave in an anomalous way similarly as well, right? So sort of next step. Now, it's a great package. It's a great package, but it doesn't handle well things like seasonality. When you have a spikes like every night or once a month or something, it will detect them as anomalous every night. For example, if there's like a backup running and you have a huge spike in I/O, it will detect as anomaly, right? It can't learn from the previous and seasonal spikes. The spikes will influence as well, because after a single spike, the next one can be often missed because they're using exponential moving averages. The data isn't always following sort of normal distribution, and they assume that it is. Oftentimes it's okay, but it may not be. And they're also working on a single metric. So if you have like 10,000 metrics, or even like 100 metrics from Oracle database, they don't do multivariate analysis, which means they consider single metric on its own, but they do not really detect unusual combination of those metrics. Let's say the I/O spiked significantly, but CPU consumption didn't, and that's maybe anomalous combination, for example. So that's how it looks like when you actually run the interface. So it will detect anomalies in here, and if you can click on them, and you can see spike in this case, and you can also, there's a, I think I'm missing the button here somewhere, which will say, do the correlation with other metrics and show me other anomalies which look like that. So it doesn't mean you have a problem at this time, but you might. And it saved our behind number of times because we could find and respond to unusual conditions while we didn't even know how to define it with the proper criteria, right? The idea is that you spot strange situations without actually knowing how to define for them, how to define the thresholds, and so on. Any questions so far? So, yeah, go ahead.
Do you collect all of the metrics possible? Or do you have to kind of work on a subset stack that you heavily work with certain scale of metrics?
So the question is, do you collect all the metrics possible and work in a subset? Well, I guess the answer is it depends. So in this example, we've been collecting a lot of metric, even the ones we would never normally look at. So we just collected everything possible. But as you get smarter, you may start throwing away some of the metrics, or you may start producing derived metrics, which we'll talk about a little later, which is like combination of, let's say, CPU consumption and network traffic, right? And SQL response time and the number of requests per second, right? So you can find other ways to actually, using your domain expertise about what you collect, to derive more meaningful metrics. But in terms of collection, depending where you collect from, and I will mention a few examples where it can come from, with this graphite component, it actually doesn't have native collector from Oracle database. It has it from MySQL, from Postgres, but not from Oracle database. It's very easy to expand if you would want to write one, and there's a lot of open source examples. But it has a lot of collectors for like hosts and other things, so it would work out of the box for that, except not for Oracle database. Does it answer your question? Okay. So I'll show a quick demo with Oracle data mining. So what types of data which are like a good operational data? Well, stats pack reports, maybe one, AWR reports if you have that licensed. Ash, possibly, but it's very difficult to work with it because it samples the data and it kind of needs some transformation before you start working with it. But usually I find that it's the data that's for the period of time characterizing your system. That seems to be the most interesting or easiest to work with. So in this example, what I've done is that I just look in a SAS sysmetric history, and I don't use AWR, but I use SAS, which Kyle actually created initially. So, and it's 90 seconds sample, 90 second snapshots, and it basically snapshots some of the common system metrics: total parse count per transaction, logical reads per transaction, network traffic per second, and etc. Right? So there's maybe a couple dozen of those. So I collected those, probably about 36,000 of those in 30 days for 90-second intervals, and we worked with this data a little bit with Alex to show some of the ways to use it. Now you can also sample or your VDOL SQL, for example, in order to work with this data set, and then you would be able to identify SQL which looks unusual, unlike the rest of SQL in your database, right? Or you can also look at the, like a wait event, for example, snapshots, and look at the unusual wait events during certain period of times, right? So there's a variety of ways you can do that. You can get the data. Or one of the things I really want to try is that actually make a plugin for the Enterprise Manager, so you can get the data of the Enterprise Manager, which has a lot of operational metrics collected, and then do anomaly detection on Enterprise Manager as opposed to setting the thresholds all the time. But it's only in my head right now. There's no code been written for that yet. So anyway, so I basically make a simple view out of this because I pivoted so that it's easier, and the data looks like what the data looks like. And the data looks basically as a snapshot and That's an ID, which is basically every 90 seconds. It's approximately, sometimes they're longer or shorter. And then we have a lot of continuous data, basically. So what we can do is that in Oracle data mining, it can graphical interface and SQL developer. And I can easily drop a data source. So that's my table or my view. And I can, those are the columns that I analyzed. I could probably see the data as well. You can see the data as well. So those are the same data we work with. It has an exploration component. I can quickly see some statistical sort of attributes of this data sets. So distinct values, average, deviation, variance, and etc. So just to give you an idea what it is, it also gives me the sort of histogram or distribution of the data, how it looks like. And you can see some of them seems to be more like Poisson distributed, others sort of maybe normal distributed or Gaussian distribution. And what you can do then is you can basically connect the data set and build an anomaly detection model on it. And I already run it here, but it runs for about a minute. I'm not going to run and wait for it. And then when this model is built, I can simply apply it on data. And I'm applying it to the same data set instead of just keep applying it to a new one. But in theory, you can basically this apply is like a SQL statement. So you can run it every 15 minutes or every 90 seconds or whenever you have a new data set and apply it to the new data set. And if you detect an anomaly, you can close a page out or send an alert through mail system or whatever system you use, right? So that's one way of using it. So basically, when I apply the data, oh, it's like something wrong, new data. So it basically predicts the way the anomaly detection is implemented in the data mining, and I actually don't know the algorithms internals, and Oracle didn't quite publish it. They use the classification algorithm and somehow split them in two classes, so a single class classifier, and 0 class in this case is anomaly, and 1 is non-anomalous. And it also predicts probability that it looks like anomaly or looks like not anomaly. So what we could do is we could basically look at, let's say, sort by, we can sort by what? We can sort by prediction, so the zeros come first, and then we can sort by probability in descending order, and it will basically show us top anomalous with the highest probability that those are anomalous. Another way to look at it, I think it's better if I just sort it by the timestamp, and then I could go through them and see where the anomaly is. So that seems like anomaly, but the probability is not very high. If I can keep going, I could find few that are high. We can try to see that. 0, 0. All right, that seems to be very high probability it's anomalous. So I could try to see if there's anything specific I can see in the data, but generally I would look at this time frame in a database and could try to understand what unusual thing happened in the database. That looks a little high, DB block changes per transaction compared to the rest, for example. What else? That looks somewhat high as well, right? So megabytes per second of I/O. Then what else? The whole parts count. So I could try to understand what the system, why the system behavior seemed to be unusual. Anything else here? So that's pretty much it. So that's what Oracle data mining has for anomaly detection. It's very kind of limited in this space, very limited in this space. But there we go. Let me get back to where I was. Okay. And now I want to give it to Alex, and he'll talk a little bit what we can do with sort of Python tools and how we can use things like autocorrelation and other things as well.
Thank you. So let me just fix this so I can get this a little higher. That's about the, I'm gonna have to. Okay, so ideally what we really want is we want some system that learns from the data as it's streaming in. And when some human eye or somebody comes and says, okay, I understood what that was, they can tag it. Then the system would update, and then if it ever saw something like that again, it would basically understand that, okay, that actually came with a negative tag, so don't tag that again. And there's a few ways to do this. So for instance, in this single class SVM that the Oracle system uses, it's essentially doing what was on this slide. Here, this slide here. So it's essentially doing something like time on this axis or some sort of index, and then whatever the value was. And it's finding the support vectors that distinguish things into two classes. So that's my guess. Now, a more sort of Bayesian approach would be to actually have a probabilistic model sitting there and updating as data is streaming into the system. So there's a few ways to do this. One way, you could basically apply autocorrelation. So autocorrelation is essentially how radar detection works. So I send out a signal, and this signal is now going out into the room, and that has some profile. And when the signal comes back to my detector, there's been added some noise that comes from some sort of distribution, like a Gaussian or uniform distribution. And then there's some return signal that comes back with some time delay. So the autocorrelation is taking the input signal and whatever that, some delay signal later in time, and seeing how much they match each other. So in the first example, we actually have an example where I'm sending a signal out, and the signal is coming back. In this example here, we just have a long stream of data, and we want to see that if there's some sort of seasonal component that's showing up as a predictor. Okay? So when you run this, you actually get some really good plots, and this is a little bit out of order right now, but let me just show you some of these plots here. So this is now the autocorrelation of one of the features, and I didn't label it here because you wouldn't have been able to see it anyway. But you see right away that out of these 21 variables, there's definitely some that have high autocorrelation. So that the axis here now corresponds to how long the time lag is before there's a huge correlation. So this basically corresponds to like a weekly pattern. So this is over 32 days or something, 32 days and a smidge. So you see right away then that this becomes a way to input into a real probabilistic model another filter, a derived filter that can be used as a feature. So once I know this data, then I can actually use it to subtract away any type of seasonal component. So now, before you would have said, okay, well, this sort of spike in activity here might have been anomalous, but now you have a way to actually subtract away its influence in a fully probabilistic way.
And that's actually interesting because the way how we work, Alex actually doesn't really know Oracle databases or metrics or
Actually, I don't know it at all. So.
Read or anything, so I gave it a data set, like he didn't really interpret the data, right? But he was able to identify and point out those anomalies, and they basically turning out to be a backup. So now I know that, but like he didn't, and he could easily figure it out from the data. But again, when you work with like thousands of systems, you don't really know what happened. So it lets you quickly get the idea, when events happen and how the traffic changes over time. And it will let us, as I mentioned in the beginning, this type of approach will let us avoid sort of night batches paging you because your thresholds violated during the night, right? But you don't have to specify it like from 1 to 2, it can be done automatically using those this approach. Yeah.
Great, thank you. So, so one of the interesting things about this is that I noticed that something was happening every day at around 7 o'clock. And I still don't know what that was because I just don't know. But it's maybe it's some sort of cron job, maybe it's some sort of something that is happening there that's causing a lot of I/O reads and writes. So that was kind of interesting. It's also interesting too because it actually never happened at the same time, but it happened within the same 20 minutes, around 7 o'clock. So something's happening. Again, just to make this clear, using filters like this, you can have these filters be part of the derived features for another algorithm. So that's the entire point here. So here's just a little bit of sort of interesting thing. Not huge correlation, but you definitely see that there's some sort of seasonality here. And when you check, you can actually tell when the weekend is and when the week is. Again, average active sessions metric. It has this sort of high correlates where there's some sort of repetitive basis, and then when I subtract that away, it helps me alleviate this problem of just setting a natural threshold. Now, let me go back here a little bit. So here I've plotted the histogram of the values coming from these 21 different metrics here. And you see mostly that these are sort of Poisson distributed, and then there's some sort of interesting ones here. This looks a little bit more like a Gaussian distributed object, and then here you see that there's sort of two humps. So what you actually want to do in a probabilistic model is you want to take all these basically density functions, multiply them together in sort of a naive approach, and then you have now a joint distribution on every metric possible. And when you do that, you can actually characterize many really interesting things. You can say that, okay, metrics X and Y and Z actually aren't huge predictors of any anomalous behavior. And so then you can marginalize those out. So just like what Alex said, you have potentially thousands of metrics coming in from many different data sources, and which ones are actually going to be huge predictors or a rich feature set for this type of prediction. This type of analysis you can do using standard tools like stats models or pandas, or so I'm sort of a Python guy, as you can tell. But there's a lot of open source tools that you can use that do this type of Bayesian modeling. So this was kind of interesting. This was, instead of just doing the autocorrelation, which is a correlation between some signal and the time lag of that same data, X hours later or X minutes later, you actually can do the correlation between different metrics that you have. And these were the ones, this is printed out from a terminal. I should also apologize, I had all this other work done, and then right before Alex and I were sitting outside, and I tried to actually make a WAV file so you could actually hear the anomaly. And it actually worked, but unfortunately I did something stupid. I used the itertool cycle generator. So it basically just started writing to file infinitely, and I couldn't stop it, and then it crashed my entire session. So now I've got a file on my computer that's about 32 days long. Right, it's 32 days of data, where you actually can hear the anomaly. But anyway, there was a lot of other stuff that I had there, but everything crashed, so I apologize. But here you see something interesting. You see that, if I now backtrack and say, what are these labels really meaning? Oops. You see that response time per transactional metric is highly correlated with average active session metric. You see things like physical reads per transaction metric is highly correlated with physical reads per second metric. So this is another way to really reduce the space, because now you can say, okay, these are highly correlated. Let me just look at one of the probability density functions. So anyway, this might be getting a little bit mathematical, but this is super fun stuff, and it's beautiful stuff that you can do using open source technology, and basically write about 20 lines of code and have something that has really high fidelity in terms of prediction, something that won't be waking people up in the middle of the night because there's a big I/O dump that was some sort of cron job, or it's just a way to with just a few lines of code actually have something that is learning as the data is streaming in. And I should also add that otw, which was this open source software, uses about only 1 or 2 different metrics. So I think you had that question, and I actually thought of that as 2 parts, which was what metrics are you tracking, or how many metrics are there? There's all these metrics that the database is dumping out, But then the actual anomaly software only really has two metrics, and I actually forget what they are, but they're very simple. And so within this framework here, you're actually using very natural metrics that come from a distributional understanding of the data.
Is it also a good indication of how you can make like a derived metric, like take ratios between them and they are correlated?
Exactly right. So one thing you can do now is that when you find these highly correlated metrics, you can take ratios or functional ratios of these things, and then those become very good derived features. So instead of having, here we've got 1, 2, 3, 4, 5, 6, 7, 8 times 2, now you reduce that into half. And those tend to have very high fidelity. So now you've reduced your space, you've done really good, basically, feature extraction from the data. So here's some more examples. Again, just these high correlates.
Yeah. One of the things I wanted to mention, I don't know if you said that, but the way, when we have understanding of the domain, what we could do also is we could look at, start looking at our feature space and produce the right metrics. And for example, you could say, okay, I want to have a ratio of network traffic to CPU consumption, because it's generally within a certain window, for example. Or I can have a ratio of CPU consumption to megabytes read and written to disk, because there's a certain, they're normally within a certain range and so on. So, and our servers or databases usually working in a certain pattern, which has sort of ranges or have certain distribution of those derived metrics, much better than just raw data itself. So that's a good way to sort of improve, I guess, the precision in here. I think that's all we've got. So any questions? That'd be a good time now.
Yes.
I got a question. If you're trying to consolidate a whole bunch of databases to the platform, got some of this data, can you help predict if there's going to be a problem if you're trying to move? Like, let's say you got a workload you want to move on, consolidate it, would this maybe help you to see that you marry the trends together somehow, if you have the data for each of the databases?
So the question is, if we consolidate multiple databases to the same platform, you want to make sure that after the consolidation you have enough capacity and they will perform well, will not conflict with each other.
Yes.
I guess it's more of a capacity planning question than sort of anomaly detection, but it's not really sort of probabilistic models you gotta use. You just need performance data in terms of, you know, what I/O, what the CPU consumption is, and you kind of aggregate that together. So I don't think any of those models are required in this case, unless I may be missing
Well, I'm thinking maybe
application.
you see the spikes going like that, and if you bring this model and this model together, you can be, you know, double.
Right, you can do like correlation with correlation, sort of simple correlation analysis. You could do that, or you could identify databases or servers that behave similarly, like seasonally, right? And then you know that, you know, if you consolidate those together, then you'll likely have a problem, because you basically multiplying your spikes in capacity, right? So you may want to consider consolidate them into different containers or whatever you're using.
So, can I just say something? I don't know if this is exactly the question, but are you talking about actual dependencies? Like, if I have to have this database come into the system before some other database, or are you just?
Well, I'm just thinking if we're trying to consolidate systems together and consolidate systems. If you've got system X, like I was saying, if I've got a couple of retail stores and I move it together, December or Black Friday would be a bad idea, because you'd see in your trend right there that putting these two together would be really bad.
Okay, thank you. Any other questions?
Can you do any causality analysis with this, with simple correlations? Can you say that this metric caused that metric?
Yeah, I mean, so I wish I had actually some of these plots. I had some of these plots on top of each other. I don't know about causation, but definitely correlation. I mean, what I noticed in some of them is that the correlation would start rising in one of the metrics, and then the other metric would sort of, so this is like standard systems response in physics, where you have some sort of lag, and then you might be able to say, yes, this thing actually caused that thing. But again, I just don't know.
Is it basically all the Bayesian algorithms that are inferred to the inference, why the prediction happens, and some other algorithms don't do that?
Yeah, that's right. Yeah. So I mean, so the whole thing with the Bayesian paradigm, which is really beautiful, is that I could just look at the mean and standard deviation of whatever the data is, and I could just say anything. If I assume everything's Gaussian or normally distributed, I could just say anything outside of plus or minus 2 standard deviations is anomalous. And the beautiful thing when you actually do it within a proper Bayesian framework is that you actually get very good confidence intervals. And so you don't have to do these heuristic rules like 2 standard deviations on a normally distributed object. And another thing that's really beautiful about that is that as data is streaming in, and as you're giving it a little semi-supervision, it's actually updating and learning that. So the actual distribution itself is changing.
That's actually what I think. I don't remember if I mentioned, but we can basically change the anomaly detection into classification if we're able to label the data, right? So if we feed the data and able to analyze 30 days and then label periods which were when system behaved improperly, when the system behaved improperly, then we can basically train it on this data set as a classifier, and then it will basically be a predictor, just classical prediction, classical classifier that this time seems to be when the system behaves, anomalously or behaves unusually. But then it will be a simple classifier, and there's so many classification algorithms and models, significantly more than just anomaly detection. So it's good if you can transform it to that. But again, if you have 1, 2 databases, you can do it. If you have like 1,000 of those, this is unlikely because it's just too laborious. Well, I think that's all.
Excellent.
Thank you for your attention.